All right, welcome to today's episode of Firefighting Fridays. I'm Jeff Diederich with Strategic Fire Training, and today we have Jeff Shupe, Jerry Knapp, Chad Gruver, and John Mateer, and myself rounding out the discussion panel. We're going to get down to some of our experiences and history with the 2-inch line tonight, and we're going to start from the beginning for us, and that was way back in the 1970s or even earlier with the 2-inch hose. Jeff, you have a lot of history with this, specifically with the Cleveland Fire Department and some of the growing pains that you guys went through over the decades with 2-inch line. So can you get us started there?
Yeah, sure. Okay. Talk a little bit about history. From what I gather, there have always been different size attack hose lines out there. Many years ago, I used to come across some catalogs from some companies and so forth that carried equipment and so forth for firefighting, and you could see the different size hose lines. So what we're seeing today, if it may come as a surprise to some people, it really isn't a surprise, because when you look at some departments had 1.5 inches, 2.5, 2 3/4, 3-inch, 3-inch with 3-inch couplings, 3-inch with 2.5-inch couplings, 3.5-inch hose. So these different size hose lines, they've always been out there. And so as we've seen time go on, we've seen things like the fire environment changing also. The demand for more water, for extinguishment, for better fire control, quicker fire control come about. And so I think this is one of the things that people need to consider, is that you want to have the highest flow you can take care of and attack the fire that way. And of course, still have mobility and things like that. So you just got to take a look at the history of the job. And by the way, it's kind of funny because you take a look at the old Shepherd book, his hydraulics and things like that. When he's got in the back there all those different tip sizes out there. Oh my God, it's always been there. And then he put the pressures and what the expected flows were and things like that. And it was kind of something that we've always taken for granted. And I got to tell you a little story. When I was first getting into the job, it was one of those things where you had fire tech classes available to a lot of guys. A lot of guys, they were using the GI Bill to go to school and get their associate degree to help them for the promotional studies. Or some departments, paid guys a premium to have an associate's degree in their field of work and things like that. We had a hydraulics instructor, the name of Richard Knapp, Knopf, and he's retired now, but my God, you talk about a wizard, with hydraulics. But one of the first things he said right off the bat, he says, "Gentlemen, there's 2 types of hydraulics in the fire service. Those that you study for promotional exams, and those street hydraulics that you use every day out in the street." Okay. So that was, oh God, I think 70, 73, 74. Maybe 75 when I had his class. And I mean, he was something, he would throw those formulas out there and so forth, talk about coefficients, talk about K factors, and all those formulas. So anything you hear today, like I say, if it's surprising to you, it shouldn't be, or don't let it be, because this stuff has always been out there. But the greatest thing that I think he gave us was that those 2 types of hydraulics. So as we look at our fire attack today and the need for more water, but we also have to have manageability and so forth. And as we've all said before, and if you take our class, especially the one coming up at FDIC this year, in a few weeks here, you'll see what we're pushing is a low pressure, high volume attack system. So I think that's one of the bits of history that I think you need to know. Whereas in the past, when fog nozzles were the big thing to have, when the fog nozzles were requiring, or still are requiring, if you have those, a higher pressure. well, that results in a greater back pressure. So as we've seen all this come about, it's given us the ability to think, okay, we got a changing fire environment. We need more water. We also have to look at things like the other things that complement fire attack, and that is ventilation or truck work. So a lot of this is history, and I don't know how deep you guys want to go in the weeds tonight on this history, but
Well, I'm interested in knowing a little more about how the 2-inch line came into the standardization process, where,
okay,
you know, at the in the days of 1.5 or even 1 inch, 1.5 and 2.5, the 2-inch walked in and it either blew people away or people kind of blew it off. So
okay, well, let me say this, and Jerry, anytime you want to step in, you know, feel free. Same thing with Chad and John. But back then, let's take a look at the types of, or the sizes of fire hoses you had. And I guess we're going back into the 70s. So many departments were using boosters, and there were 2 sizes of boosters. Remember that. You had 3/4 and 1 inch. And you were considered a real progressive firefighting department if you had a 1-inch booster. And I'm thinking, oh my God, you know, what are you going to get? What are we going to go from 30 gallons a minute to 40 gallons a minute, you know, by increasing that internal diameter? You had booster lines, 1.5 and then 2.5 for your attack lines. So here come the 70s. And of course, you know, coming out of the 60s, the fire departments, many of your urban centers, you know, you had the riots. And so the guys, you know, it was like, holy cow, we're fighting fires that are gasoline fed or things like that, you know, heavy involvement, like it wasn't expected like in the past. And now you're finding out that the 1.5 just isn't doing it. And the 2.5, like I said, those guys in those big cities during the riots, they were seeing all those fires all days, all night long, and dragging a 2.5 for those completely or heavily involved situations, and they're beating themselves up from the weight of the water and things like that. So here come the 70s, and here comes Project Fires. And we've talked about this before. Project Fires was that acronym, FIRES, FI, Firefighter Integrated Responding Emergency System. And it was a head-to-toe protection, and it was all about your SCBA, but also fire attack capabilities. They were also part of that. So that's when we started seeing the 2-inch. Cleveland had on several of their engines as a field test. And many cases, the old style brass couplings were not there on the 2-inch hose. I remember seeing European style couplings, aluminum, 1/4 turn or 1/3 turn. That's all they were. Boom, just like that. Same coupling, same style of coupling that was on the LDH hose back then. So no locking device, by the way, at that time. So you saw the 2-inch, and remember the early 2-inch was rubber line. You had your double jackets, and that was about it. That was a step in a big direction, because there was all kinds of promises that if we couple the 2-inch hose with an automatic nozzle that has a flow range of 50 to 350 gallons a minute, oh, this is going to be great for the guys. You know, it's not going to beat them up like a 2.5 would, but we're going to get a whole bunch of water. And it's just a 1/4 inch bigger than 1 3/4. Remember when 1 3/4 came out over 1.5? Oh my God, it's like, what are we going to do with this? And you know, the early nozzles, they were like this big, you know, big bumpers on the end of them and things like that. And it was a different thing altogether to get used to. So when the 2-inch was coupled with the 100 PSI automatic nozzles, and I mentioned this before, we didn't have the availability of flow meters like now. Hell, we talk to fire departments wherever we go, we tell them, you need a flow meter if you don't have one already. We get a flow meter with us so we can show the actual flows that you're getting from the hoses and the nozzles of today. So it kind of sets the tone. Like when we go in there, we talk, look, you want a low pressure, high volume system. Okay. You need a 50 PSI nozzle, not a 100 PSI nozzle. You need a hose that's manufactured out of this type of material that allows a higher flow and a lower friction loss rate as the water flows through it. So all these things, well, the flow meter helps us prove that point. Wouldn't you guys say? So there we are. So that's, like I said, here comes the 2-inch hose. And it is, geez, I don't know where I should go with this, but it's a size of hose right now that, like I said, the newer synthetic liner materials, the jacket materials, everything, the couplings. We'll talk about the couplings, maybe down the road. But all that and the nozzles allow this line to be an excellent fire attack hose line. Not that it replaced the 2.5, certainly a lot more firepower though than the 1 3/4 for that 1/4 inch diameter. So
how was the 2-inch received on the Cleveland department?
it was there. Yeah, well, that's the way it was. In fact,
how was it received by the guys? How did they like it?
Oh, no, nobody questioned it. At least not that I remember. It was actually sometimes confusing because as we were setting up, like we had a bed of 1 3/4 and a bed of 2-inch and a bed of 2.5 in some of the engines. After a fire, when you had multiple lines pulled, the thing about the 1.5 coupling was deceiving. Some guys look at it that, oh, see, it's the same hose and so forth. Then you'd have the two sizes of hose lines mixed together, rather than having a bed completely of 1 3/4 and a bed completely of 2.5, or 2-inch. So that was one of the things you had to look for. So again, there was a lot of things there about that 1.5 coupling works no matter what. And the 2 inches definitely gone through its growth. So from the early times.
I think it's really found a niche into the modern fire service for sure. One of the growing and prolific building construction types right now are what we used to call mixed multiples, where we would have like a small commercial retail business on the bottom floor, or even a parking garage, and then that may or may not be made out of concrete, and then 3 or 4 stories of wood framing, apartments above. We're getting access. You're going vertical. You got multiple turns to make, and you got a heavy fire load above you. I think that's where that 2-inch line would really pay off, as far as like an initial engine company showing up with 3. You got to get a big line inside, heavy penetration, lots of, that lower end of the 2.5 as far as gallons per minute. I think that's a winner for sure.
And you've got mobility after that. Look, two guys can easily handle 100 feet of 2-inch hose. Again, that's why we always, when we go out there and we talk about firefighting and you're stretching your initial attack line in, get all your hose from your engine as close to the fire building or the access to the fire building as you can. Because as you move your hose line in, what do you want to do? Drag 200 feet of hose with all that water weight in it? Or would you rather pull 35 feet of hose that's closer to the building, and that's what you're going to be moving in a little bit at a time?
Right.
So, all this stuff, goes in to make it a winner. And as we learn more about hose line management and things like that, yeah, you could just see it's just a great tool.
Yeah, absolutely. Well, as far as moving from, those days were project fires, and then into the 80s and 90s, and now we're seeing a real place for the 2-inch line. Is this movement towards the larger hose line, is this really going to catch on and stick? You think or are we going to kind of repeat some mistakes and fall back to doing things, I guess, the way we used to, as far as like smaller tip sizes, smaller hose lines? I mean, it'd be nice to say that we're moving in the right direction. We're going to continue to go that way, but how do we continue to, I guess, champion what is really working out there?
As you guys all know, and I think anybody who watches this will agree, the politics of the fire service today,
Yeah, it's like everything else in our society, right? We're just a
Yeah.
slice of it, you know?
Yeah. Jerry, what do you think?
I think a couple things, Jeff. I think the fires are going to dictate, and everybody's running without enough manpower. So the advantage of the 2-inch line is you get more flow, you get more fire knockdown. And the thing that always strikes me is when we do our hands-on at FDIC, like my station is, the guys take 1 3/4 inch in, then they take a 2-inch in, and I ask them, what was the difference? And they all say the same thing. Feels the same. It's a little heavier, but it's undetectable. So I think the benefits are really outweigh the, so Jeff, to answer your question, I think it's going to stick just because it works. The other thought that I think is critical, and Jeff Shupe mentioned it, is you got to have that flow meter, and you got to think about your fire attack system from the intake side of your pumper to the discharge side of your nozzle. You just got to flow it. And I've told the story before. I did a flow test for a department that was running 2-inch lines, and they were flowing 140 gallons a minute. And come to find out, the ball valve wasn't open all the way in their rig. So it's great. We can have these discussions about which is better, but you got to measure it. You got to have a flow meter. You just got to measure it. And it should be, you should think of it as a system.
Yeah, I think if we could practice and train towards perfect, then when we get into the street hydraulics, we're pretty damn close. Practice for perfect, and then when it's
Right.
game time, it's going to be
Yep.
where we're going to be in the ballpark. Like Jeff was saying, street hydraulics. We're going to be real close to what we want.
Yeah. And I think we got to be careful too. We don't depend on the calculations, because it's a theoretical calculation. I mean, you got to know that stuff. You got to understand it. But just because you have 200 feet of 2-inch hose out and whatever size nozzle and whatever size pressure doesn't mean that theoretically you're getting, 240, 250 gallons a minute. Like I said, test it, and you might be surprised. You might be pleasantly surprised too. Yeah.
And it'll never be the same twice in a row.
Yeah, typically it's, you move from a different operator or a different discharge, or, it all plays into the end result for sure.
The plumbing on the engine. The plumbing on an engine can change. Is everybody here okay?
Yeah.
Yes, sir.
Okay.
Yeah,
I believe, we proved that, John, when we got those 12 engines several years ago. 6 came with the hail pump, 6 came with what's the other one? Darling.
Darling, yeah.
They both did fine on the street, but nevertheless, they were plumbed differently. So you got an SOP that calls for a certain discharge pressure, and you will get a difference simply due to the plumbing before it hits that discharge outlet. So yeah, Jerry's right. The flow meter is a huge thing.
Mm. And where's the pressure sensor? Is it close to the pump, or is it at the end of the pipe that runs, over the axle and around over and through the woods to the end? You may. I saw an engine that lost 35 psi between the pump and the discharge. Where the hose was connected.
Mm-hmm.
35 psi.
Yeah.
Would that change things, Jerry?
Well, this company had a 2.5-inch hose that flowed exactly what 1 3/4 should have.
There you go. Hey, can I make a point about water weight between 1 3/4 and 2-inch? Okay, so a 50-foot length of 2-inch weighs about 68 pounds, or has about 68 pounds of water weight in it. And a 50-foot length of 1 3/4 has about 53 pounds of water weight. Remember, these are approximates. Nevertheless, it's 15 pounds. If you divide those 15 pounds, because that water is distributed in that over that whole length of hose, you're talking about 0.3 pounds of water weight extra in the 2-inch hose per foot. So you see why if you handle your hose properly, there's hardly any difference at all between the weight of them. So
Oh, wow, that sounds like we can make a T-shirt or a genre or something out of that statement, 0.3 pounds per foot. I mean, what's 0.3 pounds? Maybe like maybe a bunch of bananas or something. Maybe we could like make this like the lightweight attack hose and come up with a new slogan.
Yeah, and remember, and see, that's the other thing, as we all realize now, this is all approximates. You can't use formulas. Even the manufacturers of hose, they'll tell you, you can throw your formulas out the window. And it's been like that for probably 15 years, I would say, that, we haven't been able to use formulas because the materials and the manufacturer of the hoses is changing. The nozzles, the couplings, the hardware, and things like that. And, I'd hope to say it's, when we asked for hose that would expand under pressure, we got it. Then we had people that said, we don't want it to expand. We want it to hold this shape all the time. Well, you're asking for something different then. You'll get it. Might not be what you want. So these are the things about our job, We have people crying for this, crying for that, and so forth. Then we got other people who sit back, whatever they give me to work with. So,
Which I think is probably where the majority of the firefighters are in the country. You come to work and you plan on having some decent, great tools to work with and go to work and get the job done.
Yeah.
I guess where we can go with that is talking about some of the other little small details. And one is the coupling sizes and also the waterways through the nozzles, the nozzle tips. How's this all play into the 2-inch line, making that, again, a winner?
Anybody want to grab it? Anybody want to go with
We'll
this?
leave this one for you, Jeff.
All right. So as we've seen, you have 1.5 and 2.5-inch couplings that can be used on your 2-inch hose. And we've also seen the usages for your 2-inch hose. Number one, not to replace the 2.5-inch hose. Let's just get that out right now. This hose should have never been put out there, and salespeople and other people out there who were saying years ago, this will replace the 2.5. Wrong thing to do, wrong thing to create. It created a real problem for the American Fire Service. A lot of buildings were burned to the ground because hose lines were thought to be flowing more than what they actually were, and they weren't. Okay. So, and this is why we have different size hose lines, because we have different size fires that require different volumes of flow. It's just that simple. Okay. So anyways, where was I going with that?
You were gonna take us down the road with the coupling sizes and the waterways.
Okay. So one of the things that we found out was that as the 2-inch line gets pulled into buildings regularly now, because it's a great, as you guys brought up earlier when we started tonight, for that understaffed engine or that 3-member engine, they can get a line in service now that's flowing 240, 250, 260 gallons a minute, make a good hit on a well-involved fire, shut it down, and because of the water weight, they can become mobile with it. Reposition it, make another hit, shut it down, continue the process, because it's not going to beat them up as if it was a 2.5 or something like that. Okay. If you're going to take this hose line into a building, do you want a big bulky 2.5-inch coupling, or do you want something smaller? And that's where the 1.5-inch coupling comes in. You'll hear us, and all you guys out there in the audience who have been in our classes or have listened to us before, you know what we say about the 1.5-inch couplings. 1.5 is a term that denotes a certain size coupling. The actual waterway in an 1.5-inch coupling is 1 3/8 inches. Okay, it's an 1 3/8 waterway capable of flowing 500 gallons a minute. We don't need to flow 500 gallons a minute. We're not looking to flow 500 gallons a minute through this 2-inch line. Okay, we want a coupling that's, number one, universal, number two, small, easy to manage, number two, or 3, it's not going to get hung up on door sills or around the corner walls when you move it into a structure, down a hallway, around a corner or something like that. You want something that's easy, lightweight and so forth, that does the job, gives you as much water as you need for that line. And that's where the 1.5-inch coupling is superior compared to a 2.5-inch coupling. So, so there's some people who just have to have that 2.5 for whatever reason. Well, then let them have it.
I
What
mean,
size is the waterway in that, Jeff?
And the 1.5-inch coupling?
In the 2.5?
It's not much bigger. Not much bigger. I can't tell you exact number, but it's I want to say it's brought down to accept the 2-inch hose. And I want to say it's somewhere in the neighborhood of 1.75 inches. So
it's interesting. And you
Yeah.
lose a lot of the versatility, like going to, different ways that you could deploy that 2-inch, whether it's to a gated Y off of a standpipe system or off of a discharge off the back of your engine, or to tap off and extend. I mean,
right. Yeah.
if you got the 2.5-inch coupling, then you're kind of limited on what you're doing.
You are.
with it.
Yeah. And that's another thing. That's a very good point, Jeff. The universal ability of that line to be hooked up anywhere on the Fireground.
Yeah.
Absolutely. Here, let me I just happened to get a couple of
Hey, Jeff, your cat made her visit again.
yeah. How about that? So this is an 1.5-inch coupling. This is a ball valve right there. There's the 1 3/8 waterway right there. I don't know if you guys can see that.
Yeah,
Okay.
it's not, yeah.
There's your 1 3/8 orifice right there. Okay. You may find this on the end of an 1 3/4 hose with a 15/16 nozzle tip. It's beautiful. 50 PSI right here. Okay. You might find this same ball valve with the 1 3/8 waterway with a 1 1/16 solid tip. Okay. On your 2-inch line. And I think this is one of the things that we have to realize now, what's happened with the newer synthetic liners in the hoses and the jacket material, which does allow a little bit of expansion and so forth, is that in the old days, the hydraulic formulas, or the hydraulic principles would say you don't exceed your hose's diameter more than 50% with a solid tip. Well, now we can do that. This is interesting. So here you are with a solid tip for a 2.5, right? All you got to do is take this off, and what size orifice or waterway does the 2.5 have?
Yeah.
1 3/8, same as the 1.5 inches. So you see, this is that thing about knowing your equipment, knowing hydraulics, and knowing how to make it work for you to get the best flows and the biggest bang for the buck when you get your guys taking this line and working with it and so forth, okay? These things are what determine the volume that comes out of that hose line, okay? So. And by the way, yes, we're not anti-fog, okay? This is a low pressure fog that would go at an 1 3/4, 1.5-inch couplings, once again, capable of flowing 175 gallons a minute at 50 PSI. Okay. This is a beautiful thing. And they have nozzles out there right now that can flow higher volumes, like 250 gallons a minute at 50 PSI, that match very well with the 2-inch line with 1.5-inch couplings. Okay. How are we doing so far?
Yeah, great.
Okay.
As far as like gold standards too, I mean, those 25-year-old shutoffs that you got right there, I mean, they're still operating flawlessly all these years later.
That's a great point to bring up.
Yeah. Don't need to
Yeah.
tune those,
Oh, hey, don't drop them. Whenever you're on my training ground, if I see a guy drop a nozzle, I have to jump all over him like flies on shit.
Yeah.
Jeff, they're referred to as legacy nozzles.
Yeah.
There you go.
Okay,
That works well with the legacy instructors, I guess.
well, I guess.
All right, we've covered a lot of the history building up for the 2-inch line. Where else do you see the niche, guys, for this line to work here in the future? I mentioned the mixed multiples. Where else are we gonna probably advocate for these things?
Am I pointing down to you right now?
No.
Your department and department like yours.
Yeah.
That have those standpipe equipped structures. And I'm not talking about 50-story buildings. You're a small city, small town, small number of firefighters on duty. You work with other departments on an automatic aid basis. And if you got to operate off a standpipe, there's your 2-inch line right there.
Yeah.
So
That's the whole reason we went to it.
go ahead. Run with
Is,
that, Chad.
you know, in 2002, Jeff, you know him, a guy named Matt Rush from Austin Fire Department came out and set us all up for high rise and got us on 2.5, lightweight 2.5. Really wasn't that light though. And then now that we're the Quad Cities, and you know, I've said it before, you know, I work in a small town, but when you put all 4 towns that respond together, it's like a 15 to 20 station city. And we have a lot of high rises, and I'm not talking like the 50-story, I'm talking the 12 to 15. And then we have a lot of apartment buildings that are 7 stories. So after, you know, y'all showing me what the 2-inch can do, and teaching me how to use it and all it was capable of, I went out and I did a class for the Quad Cities, and we were talking about standpipe operations, and we didn't know what each other used. We wanted to see how it all worked together. So I had a portable little standpipe, put a flow meter on it, and you know, ours was we were using 2.5, so we were flowing 264 gallons a minute, no problem. You know, I think we got 270 that day. Another city came up with an 1 3/4 bundle for their high rise pack, and they didn't have a pressure gauge on the standpipe, so they didn't really know what they were opening the standpipe to, but they were flowing, I think, 120 gallons. And then another city was using 1 3/4. They were somewhere around 150 gallons. And that was when I brought up the point. I go, guys, if we have a big high rise fire or anything in one of our buildings, y'all are going to be coming to us. And if we wipe out the standpipe with a 2.5-inch hose, we've taken that whole standpipe. There's nothing else we can do with it. So once we go down to 1.5-inch couplings, and I think the other 2 cities are still using 1 3/4. I think they were in the process of starting to change after what we showed them, or what I was able to show them. We went to the 2-inch hose with 1.5-inch couplings. That put a Y in play, and we could put a Y on the standpipe. I can put my first line on that standpipe, go, and then the next crew coming in, if it's my other engine, they have 2-inch hose. Even if it's not, they're at least compatible. The second line is compatible with the Y. Yeah, the flows will be a little bit different, but you know, that was where we started using it. I remember my guys in accepting it. We're not, it's like Jeff said, we're not fighting these huge high-rise fires with all these office buildings. We're fighting room and content fires 70 feet up in the air. So if we're off of a standpipe, we still want that mobility. And I mean, I hated it because I had to say, hey guys, I might have been wrong. We don't need to use 2.5 on this. We need to kind of go for standpipes. Let's go with 2-inch. You know, we still need the 2.5 because, you know, we need that big flow when we need it. But most of the time, a room and content fire, we can knock out with this just as easy. And if it is advanced, we've got enough to get it. And it allows for other cities to come in. And I think my guys all accepted it. The guys at my department accepted it really well because, hell, anything's better than trying to lug a 2.5 through apartments and down hallways. So, I mean, they were like, oh yeah, can't wait to get it here. They were actually asking me, hey, when's it going to go on the rigs? And, you know, we have it folded in Denver loads. It is set up as our high rise pack, but you know, if we need it, it's really quick. We just set up the Denver load right outside the front of the house if it's that kind of fire, and we go with it from there.
Yeah. Yeah, I would say that if you're going off the ground level, I mean, a decent Main Street fire, I think the mobility of that 2-inch line would pay off well there as well. Like you said, if you can get the big knockdown power and the reach, you're pushing 250 gallons a minute. your reach is easily 60, 70 feet or more, you can make a big difference there with a couple of guys getting that thing around. You know, the mobility is a huge factor when it comes into, you know, fighting fires with not enough people.
You know, we've talked about it before. You know, when we do the class and we do show and flow, we show everybody the techniques we're going to hold, and Shupe, stop me if I'm wrong here. And everybody gets through the 1 3/4. We get them kind of dialed in. Even though it's 2 inch and it feels really easy, you still have to respect the amount of water coming out, because that's the one that gets up and bites the students. You know, if they're not, it feels so light that it's no different than an 1 3/4. And if you take your attention off of it for 1 second, that's when, you know, usually one of us have to grab the student and back them up real quick, or shut the nozzle down for them.
Right, because it's all predicated on flow, you know,
Yeah.
that nozzle pressure. Sure. Yeah.
Hey,
then-
Jerry, I was gonna ask Jerry to jump on that one, you know, that reaction force.
I'm not sure where you want me to go with this one, Jeff.
Well,
but-
I guess what I wanted to say, okay, Chad was making a point about the 1 3/4. And when you went to the 2.5, like with our show and flow,
Mhm.
yeah, you're flowing more water.
Mhm.
And you're gonna get a little bit greater reaction force.
Mhm.
If you go to 2.5, you got the chance to have a hell of a reaction force,
Yeah.
because you're flowing a lot more water.
Mhm.
I think one of you guys said it, you know, it's predicated, Jeff, I think it was you who said it's predicated on how much you're flowing. The greater the flow, the greater the resistance, or the greater the reaction force.
Mhm.
So, Jared?
Yeah, and that 2.5 just doesn't, the 2.5 has more mass contacting the ground. It's a heavier piece of hose. It's got more mass, it's got more friction.
Mhm.
So the 2 inch can get away from you quick if you're not, you know, principled in your stance on how you're holding it, because you're dealing with that back pressure that, because it's predicated on flow, you're in 2.5 inch hose territory, but you don't have the 2.5 inch weight
Mhm.
and the rigidity of that larger hose to keep you in place.
I think it ties in though too with what we teach with nozzle mechanics. You know, handling line, what the backup person is doing. Again, it's a system, you know, and I think the advantage of the 2 inches when we presented a strategic fire is you don't need to continually have that line flowing, pushing down a hallway. You're getting reach, get yourself set, get water in a fire, get it knocked down, see what you got, gate down halfway, move in, and that negates, it doesn't negate, but it makes that nozzle reaction manageable. And again, the system of how do you hold a hose? How do you pin it to the floor? What do you do with it? And again, look, everybody's working with not enough manpower. So, well, you know, we teach, you know, pin yourself against the wall, pin yourself against a door frame, pick up that nozzle reaction is going to be there. So let's do something smart with it. Let's drive it into the floor, and you know, we don't have to, you know, fight it with our arms, you know. So and you know, I have to look at the numbers. I don't remember off the top of my head, but it's not that much more significant than an 1 3/4. So, but it's something you got to deal with, like you all just said, you know.
From what I've seen, it's also, it almost lulls you into a false sense of security when they're doing it, because they're working it and it's working really easy. And then you'll see one of them like go left with it or something where there is that much water. And when you do something that it's not ready to do, or you don't expect it, when you're doing a 2.5, you know it's going to be a butt whooping. So you get in there and you brace for it. Okay.
Yeah.
It is what it is. And I think that's what happens is they're so surprised at how easy it is to flow. They, you know, they'll make an extreme 90-degree turn with the water, and then all your pressure is going to your left. You're not ready to hold it, you
Mhm.
know?
And that's the other thing about making sure that line is pumped at the proper pressure. And that happens quite often when you don't have it. You're over pumped. And that's the truth of that matter right there. That's where you're running into that problem, so forth. So wanted to bring up a point. So let's say a 2 inch line is pulled and you have a 1 or 2 family wood frame, and you've got that hallway, or you can make it an apartment building. I don't care, you know, whatever. I'm talking about a hallway. The fire's down there somewhere off to the side, left or right. I don't care about that either, but it's coming out of the hallway and down at you. and here you're set up with your 2-inch line right here, and we're flowing 250 gallons a minute. And that's the whole thing about, that line and its kill power from one set location. And that's the whole thing about, once again, proper nozzle pressure, nozzle mechanics for the nozzle man, and backup. This 2-inch line's easy to handle if you do those things properly, like any other hose line too. So you hit it from this one location. If you're flowing 250 gallons a minute and you're in a hallway that's 44, 48 inches wide or something like that, you should see results where you can bail that nozzle down very much to comfortably move closer or go right up to it at that point. And see, that's the whole thing about watching what your stream is. If you got 250 gallons a minute flowing out of that nozzle and you shut it down, that fire comes roaring back at you, you got another problem. Okay. Just no, that's the truth, So that's the whole thing about that. So, don't try to push a nozzle in until you see what it can do or what effect it's having on the fire. So okay, very good.
Yeah, those are all great points. And to take it a step further as far as getting the 2-inch in different places, keeping it folded up in a nice Denver fold does make it advantageous for tapping off, going longer. And I would bring that up because the limitations for that 2-inch hose, where people fall into the trap of thinking that the 2-inch is going to replace the 2.5, is when they got to go long, because that's where the 2.5 really shines. You can go long and still maintain a respectable lower pump pressure and still get the flow that you want, where you hit that bell curve eventually at 350, 400 feet in the bell curve for the friction loss. It escalates quickly, and then you end up really having to pump the hell out of it to get those higher flows. So at that point, you're in 1 3/4 land if you're going too far with the 2-inch. So keeping the 2-inch respectably to a respectable length, I think, is important. You got to understand the limitations of what you got there.
Jeff, I pulled the charts here for a 15/16 flowing 185 GPMs at 50 PSI. The nozzle reaction is 69. And I misspoke before. The nozzle reaction for Jeff Shupe, you're talking about 1.1/8 tip, right?
On what size hose? 1.1/8 is 2.5.
2-inch.
Oh, okay. So it's 1.16", right?
Right.
So for an 1.1/8 tip, the nozzle reaction is 99 PSI. So it actually is
30 pounds between those two.
Yeah. But again, this is for 1.1/8 at 266. So if we're down around 240, you're probably still down around 90. So, I misspoke before. There is a sizable, Chad, like you said, sizable nozzle reaction. I owe you one.
Well, it's hard to notice the difference if you got good mechanics, Jerry. So I don't blame you for not noticing.
There you go. That's why.
And Jerry, that's at 50 PSI for the nozzle.
Yep.
Okay. So again, bring up that point. Why would we want to over pump of that size line? What do you got? You're going to tie it down to the bumper of the engine or the truck, to hold, to support it. I mean, that's what you're going to need to do. So that's a dangerous thing when guys start talking about, well, you can over pump it, if you feel good, if you had Wheaties for breakfast or stuff like that.
It kills me. And we just like, I think it was Jeff was saying, we set this up so it should be perfect on the training ground, and we should practice with it being perfect. And we know on the Fireground, it's not going to be perfect, but it just kills me. We got people going, I didn't know there was that much nozzle reaction with this line. It's our basic play. Put water in a fire. I mean, if you don't know what you're, like Jeff, like you said, if you don't know this stuff, it's nuts. Chad says, I take my guys out every day and stretch a line and flow water. Well, good for you, because that's the basic play,
Yeah,
Shupe, I don't remember what number it is. I think it's like 21 or 22 of 25 tips for the engine company.
Yeah.
If you can hold the line by yourself, you're doing something wrong.
That's right. You're not getting enough flow. That's right.
I don't remember the number exactly. Sorry.
There's a couple of points to be made from that slide. One is, you're right, if one person's holding the nozzle during fire attack, you're probably not getting proper flow. Number two, either your manpower really sucks, or if you do have a fireman standing around and that nozzle man's got the nozzle by himself, you got a problem within your department. It's called discipline. Back that nozzle, that person on the nozzle up so they can get the biggest bang for the buck and operate it with less stress. So see that too many cases, you know. In fact, I remember a picture years ago. You got one fireman struggling with a hose line, and there's 4 or 5 firemen standing next to him, you know, and they got their tools and it looked like they're shooting the shit and stuff like that, you know, and not even giving a care in the world to this poor guy in the nozzle. So
Those
I
are
mean-
probably truck guys, Jeff. Don't worry about them.
yeah, well,
I mean, what, and I get it. And, you know, I've seen departments around here, they go with the line, everything we run the biggest nozzle possible. You know, we use the biggest 1 3/4 nozzle. We use the biggest 2-inch. If we're doing 2.5, we do an inch and, you know, yeah, we have an 1 1/8 on there, but yeah, we got the 1 1/4. So I just always use the 1 1/4 because if I'm at 2.5, I'm probably needing that big water. And there is a tendency to, you know, go smaller with smaller nozzle sizes. But I mean, if you got one guy fighting that shit, you might as well be using a bumper line.
that you know, goes back to the 70s, and I got to tell you, and I don't know if the older guys ever ran into this in the 60s and before, but in the 70s, we were told about the changing fire environment. And again, we need more flow. That was a Project Fires thing. That was a thing that came out of the riots. That was a thing that came out of the experience of many of your urban cities. As the fire duty was increasing, what were the characteristics that were changing along with that? In other words, fire volume, amount of smoke, heat, when you hit the door and all of a sudden you're right down there and so forth. You couldn't move in like you did in the old days, especially if you didn't have a mask on. So all these things were being looked at. Turnout gear. My God, our turnout gear was you know, so for truck guys, it was a hunting jacket or an Army field jacket or something like that. And, you know, a pair of gloves and a tool. Guys in the engines, we wore a rubber coat. And that was it, because you didn't want the water to get you wet. You know, the rubber would shed the water. What a thought process that was, you know?
Get half of it right, Jeff.
Yeah, right, yeah. But those are the things that, you know, we actually went through. And so as the changes came about with the fire environment, the synthetics, the hydrocarbons, the solid class B fuels, it was like more water. And by the way, we started to mention earlier tonight, we make reference to the Nozzle Man Part 1 back in 1951, and how those guys, when they went into a fire, they didn't have SCBAs. They went after the fire, they took a beating, but they were dependent on the truck guys to open that building up, especially ahead of the attack. So those guys were moving that nozzle around, pushing that fire environment ahead of them to get it out of that joint. So that's the other thing. So we got better turnout gear, we got better SCBAs, we got mandates from our people to, you know, because hey, look, you had newer protective gear and clothing, but you still had the hard leather lungers that were still around. And the chiefs and the company officers, it was a great thing for all of us. And when I say all of us, I mean the American Fire Service. They said, you're wearing your SCBA. I want to see it on your back, you know, at least have it on your back, you know, at every call that we're going to where it's required. So it got us in the right direction. And one of the drawbacks I saw from everybody wearing SCBAs is that we lost some of the values of ventilation because we're all breathing fine. We didn't understand the rest of the building's filled with smoke, but we're running around, you know, we're breathing easy and so forth. And we're not like the people in there or understanding, you know, that situation. So correct me if I'm wrong, but anyways.
I think an observation from that I have of it is in the earlier days when you had many, many more firehouses in every neighborhood where fire companies could get on fires a lot quicker because they were in essence just closer. There was just more of them. We certainly, I guess probably the most prolific story I read about was this Charleston, South Carolina, and how their reputation of getting on fires really quickly, and they pulled the booster lines and they put fires out with them because they were usually within just a minute or two of their firehouse. So as the fire service in the society grew and the firehouses, got together and more like multiple company houses, well, there's not as many of them. And I think that was a big change for the fire service because fires were able to burn another couple, 3-4 minutes before companies got there. And this is where we found out, like, hey, not only are we dealing with hydrocarbons, but fires are burning longer. And I think that might have been something that added to the mix. Like, we need some better water here. We need some more firepower to put out the fire. Does that make sense?
Yeah. Jerry, how about in your situation up there in your county? Location of firehouses and how quickly the guys get out and working together and stuff like that.
Yeah, we've got a ton of firehouses. I mean, like my first due area has 2 firehouses like a half a mile apart. So theoretically we can get out pretty quick. Just want to make a comment on a booster line. One of the first tests, we used to pull a booster line all the time. And when I first started in the early 70s, it was still a high pressure John Bean pump, and
Right.
they get 20 gallons a minute at like 1,000 PSI. And I guess the other thing that's important here too is that, yeah, oh yeah.
It was.
That sounds like a pressure washer.
Yeah,
It'd cut you in half.
a pressure washer will take the paint off. That's right.
Yeah.
So no, literally it was up in the 800 PSI range. And companies had success with that, like for 1-room fires. So what's important is you can't base your fire attack strategy and tactics and hose line selection and target flow selection on a 1-room fire. We've all put a 1-room fire out in a house with a garden hose. I mean, if the conditions are right, the doors are closed. So something I did early on with the booster line was we used to pull the booster line all the time. And like Jeff said, we got into that project fires and, let's go 1.5 inches. It was 1.5 inches at that time. So I ran some tests actually on the house I was living in to which was faster, to stretch the booster line or to stretch that flat folded dead bed of 1.5 inches. And what we found out is the 1.5 inches was faster, even with 2 and 3 people, because the booster line, I mean, it's, what it is. I mean, it's a bear. Once that goes around the bend, it's done. And so that was pretty interesting. I think that was the first article I wrote for fire engineering, and that's got to be around the early 80s. But
We got to find it.
yeah,
Find that, Jerry. I don't think I read that one. I got to get it.
I'll send it to you, brother.
Please do. Oh my God, that'd be wonderful.
I think that was right after the article had said the Philadelphia Fire Department was thrilled to get leather hose, so
I don't think it was that long ago.
it feels like it. Holy crap. But yeah, so the booster line, if you got a trash can that's 20 feet from your engine, sure, use the booster line. But if you're going to get that thing in a house, you need more people.
It doesn't make any sense. I mean, the amount of real estate that a reel takes on an engine now, it just, when you could easily pick your tool that you could put there, and just the 1 3/4 there, it's folded up, it's in the tray, just pull it and use it, Sure.
I was gonna say, make for better hose beds, lower hose beds too.
Yeah.
We have a reel. It's up on top. And hell, we use it for cleanup, and that's it. That's what we use to wash our hose and for our decon area, because hell, you have to climb up to the top of the engine to get the dang thing. I'm not even tall enough to get it. So, it's just not worth it. And I can't imagine putting a fire out with that, because
Well, that was it. I mean, again, what we were talking about here, look, the city I grew up in was notorious for booster lines. And it was a 2.5 inch hydrant line from the hydrant to the engine. and the officer, because they've had 3 people on the outside engines, that guy would pull a booster line in, right up to the fire. And if it was a good fire, inch and a half had to be pulling. Look at that, by himself and the pump operator. And so those were the things that the way the job was done back then. Now that I think that department did that right back into the 80s. And then they started making some changes. So yeah, greater flows is necessary. You're not going to get it with the booster line. And see, that's that thing, what many departments, Jerry and I were talking earlier, that many departments did away with booster lines on their apparatus to eliminate that chance that these guys, they pull a line into a house and it fires already in the walls. But these guys are standing there with a booster line. That isn't going to do the job, fellas.
Yeah.
Yeah, a lot of companies by me literally took the hose off and couldn't take the reel off and left that on, but literally took the booster hose off so they couldn't use it.
Wow.
Quick story. We used to mess with the guys with the high pressure line because, like I said, it was like 800 PSI. So we'd be at a brush fire, trash fire or something. And then the pump operator cranked that thing up. So the nozzleman, he's leaning. And of course, then he'd shut that pressure. That poor guy fall right onto his face, so that was the initiation. So
Yeah. How
I'm
many
sure
feet would be in a high pressure reel?
about 200 typically
right?
around.
Okay.
Yeah.
Okay. Yeah.
At like 25 gallons a minute. Yeah.
Yeah. 20. Hey, I remember reading that years ago. 25 gallons is 25 gallons is 25 gallons, no matter how much pressure you put behind it. It has no heat absorption, no extinguishing power, nothing.
That's
Yeah.
kind of like how
Fires are
much does
put
a
out-
pound of water weigh?
What's that?
Isn't that kind of like how much does a pound of water weigh?
Yeah, pretty much.
Yeah.
But you know what,
Pound
guys
of
would,
water weigh. Okay.
How much does a
Right.
pound of water weigh? Oh my God. I've had guys look at me like that, like, and they always say 8.34. No.
That took me a while, guys.
Oh,
too.
poor John.
Yeah, you're tired.
Well, guys, it's been about an hour, and I think we covered quite a bit of the 2-inch line here and all the things that kind of are associated with it, go with it, and then we kind of divulged into some of this other history of the job, which was good. But let's tighten it up and finish it up here for the night. 2-inch line, I think it's got some real great promise for the fire service. I think it solves some of the problems that we may have out there, or some of the ones you may not even know you have. Certainly does make a difference for our staffing levels.
Oh, for sure. Yeah.
Jerry, you want to give a little cap on this real quick?
2 inches a great line. Put it on your rig, get the flow meter out, test it, see what kind of pump pressure you need. Theory is good, but you got to measure it.
Yeah, get it measured. John, it's always good to know that Cleveland has this long history with the 2-inch line. I hope you guys can still continue to keep that on the rigs and make it work. Do you have a recent experience with a 2-inch?
No, I'm at a training academy. I don't have too much experience with the 2-inch lately. Appreciate that. But I will say, as a department, over the last few years, we really have gone to using that much more often. I'd say the first 10 years of my career, we probably didn't use it
No.
maybe ever. And now we go to fires and it's definitely a consideration. Not every fire needs a 2-inch. Not every fire needs a 2.5-inch. Every fire needs what it needs. But when you have the 2-inch and it's appropriate, it's a great line to have.
You know something, as simplistic as that sounds, John, that is so accurate. What you just said, a fire needs what it needs to be put out. And that reminded me right off the bat of William Clark, that fire has a critical flow rate. Whatever the fire is, that's what the critical flow rate has to be to go after that fire and kill it. Yeah. What a simplistic way. I'm patting you on the back there, son.
Thanks. Appreciate that.
And strategic fire now has a prophet amongst us.
How about that? A new one. Yeah, you know what? Excuse me, the 2-inch hose, whether you're running this, like a 250 gallon minute, constant gallonage, or the 1 and 1/16 solid tip. Look, it's a great line, like you guys are saying. We've seen it, we've used it, we've put it in the hands of so many people across the country. And guys, if you're taking our class, you'll be working with it quite a bit, come April. So,
That's an important point, if we're gonna be out there in April in Indy doing our thing, but folks, if you're interested in having us this year, now would be the time to give us a call and get us on the calendar before we're full up. Chad,
We are starting to book up. So if, like I said, and we're surprisingly affordable.
well, you are. I don't know if I am, but you are.
Yeah.
You're cheap.
Yeah, just email us at strategicfiretraining@gmail.com and one of us will be calling you. And we look forward to training with you. We really do.
Yeah. All right, guys. Well, thanks for keeping this going here for the last hour or so. We appreciate the opportunity with fire engineering, and we'll see you all soon. Stay aggressive.
okay, guys.